Every time you type a prompt into ChatGPT, Claude, or Gemini, something remarkable happens behind the scenes. In the next 9 minutes, we'll peel back the curtain and see, step by step, how a large language model turns your words into a response. A large language model is a neural network trained on enormous amounts of text. Its single job, given a sequence of words, predict the most likely next word. That's it. Every impressive behavior, writing code, answering questions, even reasoning, emerges from this one objective. The model doesn't understand language the way you do. It builds a statistical map of how words relate to each other, then navigates that map at lightning speed. Before the model can do anything, it needs to convert your text into numbers. This step is called tokenization. The text is split into small pieces, tokens, which might be whole words, parts of words, or even single characters. For example, the word unbelievable might become 3 tokens: un, believe, able. Each token gets a unique integer ID from the model's vocabulary, a fixed dictionary that was built during training. Think of it like assigning every word piece its own barcode. Raw integer IDs don't carry meaning, so the model looks up each token in an embedding table, a giant matrix where every row is a high-dimensional vector. These vectors live in a space where similar meanings are close together. King minus man plus woman really does land near queen. This isn't magic, it's geometry learned from billions of sentences. Each vector might have 4,096 dimensions, far beyond what we can visualize, but we can project them down to 2D or 3D to see the clusters. Now the model has a list of vectors, one per token, but it needs context. The word bank means something different in riverbank than bank account. This is where attention comes in. Attention lets every token look at every other token and ask, how relevant are you to me? The answer is a set of weights, a probability distribution, that tells the model how much to mix information from each position. Here's the mechanism. Each token produces 3 vectors, a query, a key, and a value. The query of one token is compared against the keys of all tokens using a dot product. High dot products mean high relevance. These scores are scaled and passed through softmax to get the attention weights. Finally, the weighted sum of values becomes the token's updated representation. And this happens in parallel across many heads. Each head can focus on a different relationship. One might track grammar, another might track meaning, another might track position. One attention layer isn't enough. Modern LLMs stack dozens, sometimes over 100, transformer blocks on top of each other. Each block has 2 parts, the attention sublayer we just saw, and a feed-forward network that processes each token independently. After each sublayer, the output is added back to the input, a residual connection, and normalized. This keeps gradients healthy during training and lets information flow freely through the stack. As tokens pass through layer after layer, their representations become richer. Early layers capture syntax, middle layers capture semantics, deep layers capture abstract reasoning patterns. After all those layers, the model has a final hidden vector for the last token position. This vector is projected through one more matrix to produce a score for every token in the vocabulary, tens of thousands of scores. These scores are called logits. A softmax turns them into probabilities. The model can then sample from this distribution. Maybe the has a 30% chance, a has 15%, my has 8%. A temperature parameter controls how adventurous the sampling is. This process repeats, the chosen token is appended, the entire sequence is reprocessed, and the model predicts the next token. One word at a time, the response is built. After all those layers, the model has a final hidden vector for the last token position. This vector is projected through one more matrix to produce a score for every token in the vocabulary, tens of thousands of scores. These scores are called logits. A softmax turns them into probabilities. The model can then sample from this distribution. Maybe the has a 30% chance, a has 15%, my has 8%. A temperature parameter controls how adventurous the sampling is. This process repeats, the chosen token is appended, the entire sequence is reprocessed, and the model predicts the next token. One word at a time, the response is built,